Super. So let's get started. Welcome everybody to our Conscia webinar on Wi-Fi 7. Are you ready? Really looking forward to this session together with you. We'll go over this very exciting Wi-Fi generation 7. So stay tuned. And as always for the webinar, make sure that you connect with the audio so you can hear us. And you are muted by default. We will, of course, record this webinar and we will share it with you afterwards. And please use the chat to ask us questions. In general, I think we will, if there's smaller questions, we'll try to address them as we go along. And otherwise, we'll have a wrap-up session at the end for Q&A. And there will be time for Q&A. And typically, this type of topic is also spans a lot of both technical stuff and general stuff. So please ask us questions. We also have support also from other people in Conscia to answer your question. And also, don't be alarmed. There is a survey popping up after the webinar is done. So that's what it is. So for those of you who are new to Conscia, Conscia is a pan-European player, provider of IT infrastructure and services across 10 markets, I would say, 10 countries. And same core focus with a lot of expertise, a lot of technical people. And we really love technology and love to speak to our customers about new stuff like Wi-Fi 7. So that's about us. And today we are actually sending from the Stockholm office. It's a little bit grayish, a little bit light snow outside. So it's me, I'm Richard. I'm the pre-sale manager here in Conscia, Sweden. I'm also responsible for our networking portfolio. CCIE from before, and I've also been working with networking since around 2000 or 99. So, and you?
My name is Claes Karlsson, CCIE Wireless. So also based out from Stockholm office.
So that's us. So let's kick it off. What we're going to talk about today. We have a number of things to cover. I mean, we'll start easy, also on a little bit introduction on where we are now with Wi-Fi and also looking at the work with the standardization of Wi-Fi 7 or where we are at the moment. Obviously addressing also important things like client support and also the capabilities in the network platforms that we have today. And then we'll deep dive a little bit together with Claes and look at some of the capabilities and the introduction of the technical aspects of Wi-Fi 7. And then I'll take it back and deep dive a little bit also on the Wi-Fi 7 security part, which is also a key thing about Wi-Fi 7. And at the end, we'll hopefully give you some insight also on how to implement, how to be successful with Wi-Fi 7. We'll summarize and then also we'll address some of the questions at the end. So, nice, interesting thing with Wi-Fi. Where are we today? I mean, most of our customers would say it's probably the primary medium. Most organizations will say that today. And it's very, very related to users. I think it's very users are typically very, very well aware of Wi-Fi and the capabilities, and also sometimes when they have issues, they're very aware of that. It's expected that maybe 60-70% of all broadband traffic has some original sort of origination from Wi-Fi, from a Wi-Fi connected device. I don't know if that parameter is very significant, but it's quite telling that it's definitely at the primary medium today. It has also become more and more as an important carrier for IoT applications, connected devices in different aspects, more and more of that. And our honest opinion is that Wi-Fi can support most type of applications today, as long as you follow some guidelines on the design and such things. Maybe there's some, telesurgery, whatever, so that maybe it's a little bit stretched, but I think, for most other applications, Wi-Fi has enough capacity, has enough sort of guaranteed latency. And also we'll see in some instances, but that Wi-Fi is also an enabler of applications where, for example, wayfinding, other things are enabled by the Wi-Fi platform or capability itself. And also, we're not going to cover that today, but I mean, there are new technologies coming up where you actually can use Wi-Fi sensing, for example, to sense if it's a person sitting by the computer or not, just by, finding out the difference for the radio waves using the Wi-Fi radio. So interesting, and stay tuned to more interesting stuff in the future. And it's been an evolution, right? It's been quite a journey so far. Myself, I was part of that very early on there. That was one of my interests to work with Wi-Fi, start work Wi-Fi. So it's been 25 plus years here of development. And it's always been a balance, right, between capacity and stability and also compatibility. Because remember, if you have a cable connected, then you're sort of hooked together with a network. But Wi-Fi is still, I mean, it's still up to the client to decide what they want to do. So client behaviors and stuff is still a key parameters for this. So the compatibility thing has always been not an issue, but it's been a question at least. And I mean, for long here, there's been sometimes been big leaps when it comes to capacity, and sometimes more on the stability side, latency side. And through all this, we're talking about 802.11 something standards there along the way. And that's IEEE is the organization that is responsible for those standardization, also for Wi-Fi 7. But also from day-to-day life, I would say Wi-Fi Alliance is also playing a major part here with testing compatibility, also pushing for higher security, and in general sort of being an association of the key players in the industry. So very, very important. And if you ask me, if you ask us, I mean, which standard here along the way provide the most benefit, I would in general say that Wi-Fi 6 was such a major breakthrough. I would say containing many ways to make the medium more efficient and attractive and less latency. So Wi-Fi 6 is still the biggest concern. If you have something before, then we're saying that, if you before Wi-Fi 6, let's upgrade. So that's our opinion. So how about the standard? I mean, you can hear about the standardization works, right? It's typically a number of years. It starts on as a early idea, and then it goes into different levels of drafts and different versions. And IEEE decided to approve this draft 7.0 in November 24, and that is what will be called the IEEE standard 802.11 BE 24. So it's done, but it's maybe not published yet. They still have to polish the text and the wording and such things. So what can we get? What can we expect from Wi-Fi 7? I mean, we're not here to talk about gigabits or whatever today and tell you, promise you that this is what you're going to get. But we can say from already this, it's a lot of capacity, really, really high capacity, and also lower latency in Wi-Fi 7. We'll touch a little bit more on that. What we see is also a real push to start using the 6 gigahertz band. That's another frequency band, very, very powerful to build networks using another frequency band. Klaus is going to cover that a little bit more. Also interesting, we'll cover technologies like simultaneous use of multiple radio bands from the same client, called MLO. We'll touch on that. We also see a high push for security, with WPA3 being mandatory in Wi-Fi 7. So that's something good. And to be able to call yourself a Wi-Fi 7 certified or Wi-Fi certified 7 device, for example, then you need to fulfill those requirements. And that's the Wi-Fi Alliance that's pushing for this one. So typically any client you see has to, fulfill those requirements to be able to call that. We'll deep dive a little bit more on those a little bit more. And I also always get the question, is there any device support for Wi-Fi 7 just yet? Or is it too early? Well, actually, I think it's, in the fall, started a lot of devices coming out, including iPhone 16. And they all, the Wi-Fi, iPhone 16, they all support Wi-Fi 7. And then you have chipsets from Intel, Qualcomm, Broadcom, and Samsung. So it's definitely getting there. Not the latest MacBook. Maybe a next generation. Yeah. Sorry, Klaus, on your device there. But also you can look and see on the Wi-Fi Alliance where you can look for certified devices, and I generally think that's a good idea. If you, for example, getting a new platform for your clients, why not check if they're on there, if the chipset is on there? I know some of the vendors like Apple are a little bit reluctant sometimes to be on that compatibility test, but anyway, they are. So how about compatibility? Well, obviously there's standardization, so you need to be compatible. But the behavioral things with how a specific client behaves in different scenarios with different mechanisms and stuff, and together with operating system, maybe that's not 100% just yet, but that definitely getting there. And how about the networking equipment there? Obviously, we're a Cisco partner here. So we have played around with the 9176. It's actually not on the table, but we have it in the lab here. So we'll be playing around that in the last few weeks. network devices are available in Wi-Fi 7. So Cisco has launched their initial products and they're deliverable. And also these models are no longer having a country code, so they can be shipped anywhere in the world, and they will automatically tune into that different region where they are. And also you'll see Wi-Fi 7 being the pusher for higher requirements for switchboard power and port speeds. You don't have to follow that, but it generally we see that now is probably the time that you probably need to think about these aspects. We're not going to deep dive into this hardware, but in general, I would say, a typical high-end enterprise access point today has multiple radios with the capabilities here of 2.4, 5, 6 gigahertz, and also some IoT Bluetooth radio, and also ultra-wideband, and also keep internally also having a GNSS GPS type of receiver, so you can position yourself, so to speak. So more about that later on, but that's much for the intro. So I'm going to hand over to Claes now and cover a little bit more on the details on the different types of mechanisms that play part of Wi-Fi 7.
Yeah. So let's go down to the fun technical stuff. We're going to cover some totally new features, calling multi-link operations. Then we're going to go forward to how we are improving the bandwidth, the throughput overall with Wi-Fi 7. And of course, a lot of things about efficiency, using multiple resource units and preamble puncturing. Then Richard is going to continue with the security part, with the WPA3. It's a major thing in Wi-Fi 7. But we're not going to cover compressed block ACK. It's been there for a long time. It's been enhanced from 256 to 512. And it's basically, you're confirming a block of acknowledgement frames instead of sending one acknowledgement per packet, basically. And we're also not going to cover the triggered uplink access optimization. And it's a technique that enhances uplink communication. Really means that the access point initiates and controls when the client is allowed to send its uplink packets, really. But what has the latest two standards now, 6E and Wi-Fi 7, brought to us? It's a totally game changer. The 6 gigahertz frequency. It's available, as I said, since 6E, but now it comes with Wi-Fi 7 capabilities. And why do we need it? Well, it's because we have very heavy utilization on the 2.4 and the 5 gigahertz bands. We have everything from microwave ovens, Bluetooth, camera devices, baby monitors, even radar on the 5 gigahertz. And all that together with we also have other Wi-Fi devices that is not our signals, so to speak. So it's being heavy utilized. So another frequency is like another highway lane has opened up for us. And due to some local, regional regulatories, we don't have the full access everywhere. For example, up here in the north, in Europe, in Sweden, for example, we only have access to the Uni-5 part of the 6 gigahertz band. As if you compare to the United States or Canada, they have the access to the upper band also, like Uni-6, 7, and 8. And it's very important to be aware of those, local regulatories in which regional your APs are operating in, because it will definitely affect your channel planning and dynamic bandwidth selection. So keep in mind in where your APs are operating in. And don't sit and wait for additional spectrums. In some parts of the world, they are opening up, and in some parts, they are bringing it down, the access to the available channels and frequencies. So it's there and it's ready for use. In my opinion, one of the coolest techniques that I've seen in the Wi-Fi standards over the years, the ability to be connected to different links or frequencies at the same time from a wireless client to an access point. And this is done by, I can maybe explain a bit more. They are calling different links, different frequencies, different links. So 6 gigahertz frequency, 5 gigahertz frequencies, that's 2 different links. And the 2.4 is also a different links for it. And what do we need? We need to have an access point and a multi-link device, and we also have a wireless client. And those obviously need to have support for different frequencies for this technique to work. But we have the ability to basically create like a port channel by speaking networking terms. We can aggregate different links and send and receive data over different links at the same time. And this will bring us higher throughput, but also the ability to steer the traffic. Let's say, for example, I'm connected to 2.4 gigahertz and I'm suffering from some bad interference. Well, then maybe my client can listen on the 6 gigahertz and listening to that frequency and hearing that, oh, this is much more better. Then I can steer my traffic from this bad 2.4 over to the 6 gigahertz link. And that will lower my latency overall. And of course, with access to multiple links, I have the redundancy, which will make my Wi-Fi more reliable. And of course, how is this being done? We have 2 major things here. We have single radio and we have multi-radio. And a lot of acronyms, as we see here. Multi-link single radio, meaning only one link operational at a given time. And then there is enhanced multi-link single radio. That is quite similar to the multi-link single radio. You only have one link operational at a given time, but you have the ability to listen to several links at the same time. So if you go back to the steering option, this is a really good one where you can be connected to one link and still listening to the others and steer away traffic if you're suffering from interference. Then there is multi-radio. Multi-link multi-radio. It comes in 2 flavors: simultaneous transmit receive, STR, and then there is non-simultaneous transmit receive, NSTR. For the simultaneous transmit receive, each link is operating totally independently for the transmit and receiving, meaning I can send on 2.4 and receive on the 6 gigahertz frequency at the same time. And this is probably one of the one with the highest capabilities.
So what's an iPhone 16? What does it support?
Yeah, the iPhone 16, for example, it supports enhanced multi-link single radio. And to be certified as a Wi-Fi 7 device, you need to support MLSR or eMLSR. So that's the classification for Wi-Fi certified devices today. But if I go back to the non-simultaneous, that meaning I have to transmit or receive at the same time on different links. So it will probably demand some correlation between the access point and the station, meaning if I would like to transmit over several links, for example 2.4 and 6 gigahertz, I have to do it on the same time. So we will see how it works in the future, but it's a really cool part. It's totally new, and yeah, of course different vendors implement and support different modes. Something that brings up the speed is the development of the modulation technique. In the latest standard, Wi-Fi 6 AX, we had a 1024 QAM. It was supported. So with 1024, 1K QAM, you're sending 10 bits per second. With a 4096 4K QAM, you're sending 12 bits per second. And you're sending bits in binary forms. So when you're upgrading from 1024K to 4096, sending from 10 different bits to 12 bits instead, it gets 4 times, you're sending 4 times more data. And it's quite difficult to explain this, but I will try. So for example, we have the 16 QAM modulation, the one most to the left in this scheme. With a 16 QAM, you're sending 4 binary bits, which gives you a possibility of 16 different values being sent. And we can see here in this 16 QAM scheme, every dot, or in every scheme, one dot is representing a value. Okay? And how to interpret this, let's say, for example, Rickard is holding up a dart table with a 16 QAM. If I would like to send the dot one in the top left corner, how do you interpret this? Well, it can be like throwing darts. So if I would like to send a specific dot to Rickard, I will throw a dart. Okay, so to be able to hit the correct dot, probably not too difficult on the one most to the left, but as you move up to maybe 256 QAM or even 4K QAM, it becomes very difficult to hit the specific dot I wanna hit. So it means I need to be close or have extremely good aim. And translating this to a RF language and Wi-Fi language, meaning I have to operate very close to the AP. I have to have a good signal strength, and also have a very good signal to noise ratio for Rickard to be interpreting these signals correct. And as we look at the numbers here, we need to have an SNR above 40 dB for this to work well. And honestly, it will demand a lot for the clients to be able to level up to these modulations. Another thing that also brings up the speed is the capability of wide channels. We have had 160 megahertz wide channels for a while, but now with Wi-Fi 7, we have the ability to have 320 megahertz channels, and mostly because of the 6 gigahertz. And together with the MCS 12 and 13, we may reach the highest data rates. As we see in the 320 megahertz, we can reach a data rate of almost 2.9 gigabits per second. And those data rates are with a single spatial stream. And one thing to mention, I would like to mention about the spatial streams. You have probably read a lot of Wi-Fi 7 and the theoretical maximum spatial streams, and they're saying that they support up to 16 multiple spatial streams at the same time. But we will probably not see this out in the wild, mostly because of the vendors don't really implement this. They usually implement like 8 spatial streams, 8 times 8, and if you will look at the clients, they only have support for 2 or 3 spatial streams. If we look at the wide channel width again, in Europe we only have 320 megahertz channels. Will we see it? Probably not. If we look at the high density designs, we don't often go above 40 megahertz really.
You can try it at home, right? If you only have one access point and a new client, then
yeah,
you might be successful with 320.
Yeah, of course. And this will also you have to operate close to the AP for this to be operating well. If we look at the efficiency for the wireless network, Wi-Fi 7 is a lot of efficiency. And one thing that has brought for this is multi-resource units. The resource units actually comes in from OFDMA, orthogonal frequency division multiple access. It allows multiple clients to transmit or receive from an access point at the same time, sharing airtime basically. And it allows subcarriers to be grouped into smaller portions, which are called resource units. In Wi-Fi 6, we could have one user assigned one resource unit. But that will also some kind of limit the efficiency, because while you are assigned one specific resource unit, it could happen that some resource units was left alone in one transmission. So with Wi-Fi 7, they come up with a multiple resource unit, assigning one user up to one user multiple RUs. So you can have one user assigned 2 RUs, which will increase the efficiency and the latency on the wireless network.
I mean, also this OFDMA, that was also one of the reasons why I said Wi-Fi 6 was a game changer.
Yeah, really.
That was introduced in Wi-Fi 6. The possibility to divide the medium into sub-channels, sub-carriers, and I think that meant a whole lot of difference for the Wi-Fi medium.
Yeah, it's a really big change.
So, for example, we all know that we have different types of traffic, right? I mean, high capacity bandwidth, file transfer thing, or maybe not what you use every day or all the time. But I mean, it's a lot of chatter, right? A lot of small chats, also with voice and video calls and stuff like that. A lot of small packets, so it makes sense to be able to differentiate the medium.
Yeah,
to low latency.
Yeah, and even with the Wi-Fi 7 and multiple RU, you can have, it could mean 25% less latency compared to Wi-Fi 6. So it's
and that in turn was a significant decrease of latency before that.
Really.
So really,
that's Wi-Fi 6 is good.
Yeah.
Wi-Fi 7 is crazy. Really, really good. When we're using wider channels and bonded channels, we are prone to experience interference because we're using we're sending over several frequencies, right? Using several channels. So without preamble puncturing, I could, for example, have an 80 megahertz wide channel, and I could experience some interference on one of these channels. And without preamble puncturing, the whole channel width would decrease to 20 megahertz instead. So we can see here to the right, we have a lot of wasted channels, but with preamble puncturing, we can still have the 80 megahertz. And when we're experiencing some interference on one of the channels, only that channel is being avoided. So we're still using most of the channel bond here. So for example, with the 80 megahertz wide, we're experiencing some interference on one channel. We are still using 60 megahertz of this original 80 megahertz. So it's very efficient. Again.
Does it say that we mean that it's 80 megahertz the way to go there? Because I mean, you have to. When does it kick in? Is it?
Yeah. It only works when it's at least 80 megahertz.
Yeah.
So 80 megahertz and above, then we will have preamble puncturing, and it was optional in Wi-Fi 6. Now it's mandatory.
But I mean, take that together with a new frequency band, it should be doable, right? So
yeah,
to be 60 gigahertz.
Really. Okay.
Nice.
One thing about WPA3.
Yeah, when we talk about Wi-Fi 7, we go into the Wi-Fi 7, talk a lot about security, and that doesn't include that Wi-Fi 7 in itself had, you know, a lot of things to do with security, but what Wi-Fi 7 is doing, it's actually pushing the demand, the requirements on Wi-Fi security. And that's a very good thing that we want. I mean, the medium of Wi-Fi is, you know, it's obviously prone to, you know, it's an open medium in the air, right? So the security has always been and probably always will be a sort of a topic for Wi-Fi. So what's going on with Wi-Fi 7? So I mean, in most of our customers' networks, I mean, you people have something like this. You maybe have a guest network. It's what we call open, so it's not encrypted. Maybe on that you have a web portal. Then maybe sometimes you have some pre-shared key type of networks. It could be used for like bring your own device or where you have a shared key. It's encrypted, but maybe in a less fancy way, but it's a sort of static pre-shared key. And then maybe some of our customers also introduced more advanced functionality like IoT networks and stuff where they use IPSK, which is like an individual pre-shared key where you have the ability to have multiple pre-shared keys, you know, for different devices. That's typically sometimes used as well. And then on the internal users, I would say most of our customers are using something like WPA2 together with .1x enterprise authentication. So they use, you know, certificates or credentials together, maybe some directory service or in the background. And encryption is dynamically negotiated. So this has been quite good, you know, level. But I mean, there are some flaws in this, especially, for example, having an open network for the get part. It's not that's something we want to address. So we've had WPA, it's definitely not new, and not even WPA3 is new. It's actually in 2018. It's been rather slow, the adoption. That really isn't that is something bad with WPA3, it's just that, you know, vendors and operating systems, including Microsoft, has been sort of slow on pushing this stuff. They haven't really seen that it's that important. But Wi-Fi 7 really says you have to have WPA3. So that's a good thing that we acknowledge. And obviously looking into details, messy slide. It's one of these slides like more of an iceberg principle, right? So you sort of summarize some of these connection methods or encryption parameters or authentication parameters. They call it typically like open OWE, for example. But I mean, underneath, there are a lot of details here. We're talking about these AKMs, we're talking about ciphers, we're talking about different cryptography stuff on you know, it's quite advanced. But why is this relevant? It's pushing towards higher encryption, better encryption methods, better ways of negotiation of keys, for example. So we see a development there, and this is much thanks to Wi-Fi Alliance, that they're pushing this. So if you compare to Wi-Fi 6, there was no real sort of true governance on what security level you would use, because most people will still use it anyway, that level of security. With Wi-Fi 6E, which was more like to my opinion, sort of short-lived, because then Wi-Fi 7 came, and that's Wi-Fi 7 compared to Wi-Fi 6E, for example. Wi-Fi 7 is a capability for all frequency band, so that the push for Wi-Fi 7 will be higher. But looking at this encryption part, Wi-Fi 6E, when we introduced the 6 GHz band in the first place, then at that point there were requirements to raise the security level here a bit. But what Wi-Fi 7 does, it takes it even further. So we have to push it a little bit more to higher encryption standards as well. Important also, I mean, in an enterprise Wi-Fi platform, you can still have different SSIDs, I mean, logical virtual networks, so to speak. They can have different security methods. And in most platforms, you can have security methods that are less secure, but they will not enable a Wi-Fi 7 connection speed or connection capability. So you can still have them. It'll be a 2.4 or /5 GHz band for legacy reasons, but it will be stuck on editor level AX. That means Wi-Fi 6. So it's not terribly bad, but it's not really pushing the higher rate, and you will also not be able to use this fancy MLO that we're kind of excited about. So classic network open, new network introduce new different levels, and definitely pushing for WPA3. So what does this mean in reality? For the Wi-Fi security, the internal network enterprise environment, it's not a groundbreaking development here. It's more like a push for higher security, right? So you don't need to rebuild your infrastructure here. We just need to be, keep on doing 802.11x, not 11x, 802.1x, of course, authentication using one of the EAP methods. The EAP methods are mentioned here, but that's not because they're really tied to Wi-Fi 7, but you typically see them in together with a standardization or for a client if they support this type of things. But most of those EAP methods are actually negotiated between the client and the radio server, and not so much on the network portion of things. But you really need to support higher security here, also pushing up to 256. You need to have PMF, that's protected management frames, enabled, and that's a good thing also because some of the packets, including when a client is deciding to join an access point, those packets are called management frames that they regulate some of the connectivity there before the actual traffic comes around, and that traffic has been susceptible to sort of you can do some certain level of attacking towards that's a good thing. So Wi-Fi 7, WPA3, not a big issue. It could be a discussion with your client teams, how to push that out to the clients. I mean, sometimes maybe you need to use Intune to push that profile out to a client or other method to do that. So, but higher security, definitely. And sometimes this is also going a little bit deep. I mean, fast transition is a topic that's been around for quite some time because every time you use 802.1x, takes a little bit while for that negotiation, that authentication. So this is a technology that's been around. It speeds up roaming, and in general, it's suggested that you use that. I don't hear a lot of people anymore complaining about roaming issues. Do you, Klaus?
No.
But I mean, it used to be a big thing. But I mean, if you're using 802.11r, called FT, fast transition, if it works for you, you should be able to use it again with Wi-Fi 7. But if you're not using this, don't just turn it on and go home. Just try it out before you're rolling it out, or maybe try it on a new SSID, for example. And there might be something. This was from an Intel slide, so you'll see, for example. But I think for most part of it, I mean, it's applicable for 802.1x network. So so that's fine for Windows and Linux. And in a home or pre-shared key environment, you can still use a pre-shared key. So WPA3 is not moving away from a pre-shared key, but it is using a more strong sort of key establishment protocol, which is much more resistant to any type of attack. So this has been an issue with WPA pre-shared key typically being, after a few years, there's been some kind of attack available that you can do. And this is much more secure. Again, you need the management frames. And you will typically see that WPA3 in this context is not truly supported IPSK. So having multiple identity pre-shared keys is generally not supported. That's the reason, because there's sort of another key involved here. So you sort of, so there's a unique key for every single session, so to speak. So there are specific solutions where you could sort of tie the MAC address of the client and saying that it's just for this client. But in general, IPSK was introduced to get away from that and to be able to sort of bring your own key type of thing. So that's a bit of a challenge in WPA3, but we're getting there with solutions. So, but anyway, security is definitely going up here. And in a guest environment, I mean, Wi-Fi 7 is quite strict here. WPA3, it doesn't support open mode, so you will not see an open guest network like you have today. But then again, I mean, a lot of these networks open so you can sort of sniff what the other client is doing, if it's not encrypted. So that's something we want to get rid of. So this new setup is called Enhanced Open Network with something called opportunistic wireless encryption. And this opportunistic has the name is because both sides they don't share anything particular, right? There's nothing they can agree on because they haven't exchanged any key or anything, not just yet. But with some magic here, they find a way to sort of negotiate some kind of low level of encryption, and in that encryption, process, then you could derive pairwise master key, which then sort of will be the enabler to generate the exact specific encryption keys. So again, you still need a captive portal, right? Because there's no authentication or device authentication in the standard, so to speak. So if you're using a guest portal, you'll still use a guest portal. And you'll see in another slide there, because I have to introduce something called transition mode. This is sort of a reference slide, a little bit, a lot of details. But the reason behind this is that for devices that maybe you need to support WPA2 at the same time as WPA3. And that also typically includes, I mean, it's for 2.4 and 5 gigahertz. Because again, 6 gigahertz, Wi-Fi 7, you need to have WPA3. There's no sort of, you cannot enable that. It will not work unless you use WPA3. So for 2.4 and 5 gigahertz, if you want to be sort of handling both worlds at the same time, there are something called transition mode. That's a feature of the platforms. It can be called different things. That means that we support multiple ciphers at the same time, or multiple AKMs. And AKM is the authentication key management setup, so to speak, sort of a method. But we need to have a PMF, and we need to adhere to some other things. So 802.1x, if you use such an SSID, you can do transition mode, and also if you use a feature key. But for OE, it's a little bit different fashion, because in that case, I said there will not be supported any open mode, so the open mode is sort of dead. But the slide, the sort of picture here to the right, that actually means if there's two networks at the same time, but at the back end, they're connected to the same logical ID, so to speak. So that means that you can have an open guest network available as they have before, but in the background, there's also another capability, but that network is hidden for the client. So there's some signaling involved there. But I mean, that's, and this is not supported by all clients just yet either. So there are still some things to do. So funny or not, but I mean, actually the guest network is sort of the issue with WPA3 and not the enterprise SSID. Yeah. And also we'll wrap up with the deepest of topics, and that's MLO. I mean, you talked about MLO, Claus. But MLO is a little bit this multi-link operation that requires obviously the same encryption method for those bands, because you cannot have a secure, not secure, secure, and that wouldn't work, right? So the client and the network need to agree on that. That means that if you want to use MLO, you need to have an encryption authentication sort of level that is okay with all frequency bands. And that means that for an enterprise SSID, there are such common ground where you can meet and you can handshake on a method that will be supported both with Wi-Fi 6 and 7, so to speak. But you need to have a PMF on that. And then that will work with MLO, I mean, depending on the client there, and also for a WPA3 connected client. So a new iPhone with a 802.1x connected to a new network, or where it's set up correctly, you would be able to use MLO. But MLO in a pre-shared key network, or also in an open network, that's another story, because that could be challenging, because it's more difficult to find common ground there. So you might need to drop some support here, and that will maybe affect some older clients. But again, this is a way of, in a typical network, you'll have different SSIDs, right? So they will be covering different things. But if you're aiming to use MLO, then for now, I think, your best bet is to use the strong security network 802.1x. And for example, in an OE environment, I mean, if you only have an OE, only use WPA3, I mean, if they're on that network, and then that's fine, right? Then they can use MLO, but there will be no legacy support to the same SSID. So a little bit deep dive. This is for your reference. This is something you can read on, but you might see in some release notes for some clients, for example, that there are some maybe challenges on a version, or MLO is not supported, MLO is supported, or something like that. So then you know what it is at least. So does that make sense, or does it sound really advanced? But I mean, so what's the strategy? Again, WPA3 is not new, but it's definitely time to go and do it. So policies. What policy can you take? Oh, you can go all in, right? You can log into Wi-Fi network, you reconfigure everything at the same time, and then everything will be sort of get it over with. But I mean, you might find challenge with that, right? And there might be some clients. It doesn't have to be old, but it could be legacy. It comes to operating system and or other things, drivers, and it could also be complex for guest visitors. I don't see your guest network anymore. Don't you have it? Well, it's still there, but so that's the way. So I mean, most people will probably see that you will have multiple SSIDs, for example, one network for a specific application. But the problem is, if you have too many SSIDs, who decides what SSID you should join? The client decides themselves, right? So it could be a challenge, and it typically could be a long way to migrate away from them because it's enough with one tricky client that's using the network, and maybe that client is not available for reconfiguring, or maybe it's coming and going, and that's a difficult thing. And sometimes there are different restrictions in the configuration. And then you can also try your luck with these transition modes if you really know that you want to support both of them, but it might be difficult to speak. So just to wrap up here, Claus, I mean, you work with this every day. You're consultant with Wi-Fi. I mean, what is what are takeaways on how to do it?
How can we do it? How can we implement Wi-Fi 7? First of all, I want to compare the 5 gigahertz to the 6 gigahertz. As we see, the 6 gigahertz is similar to 5 gigahertz, but it's a bit smaller. We do have a bit smaller Wi-Fi cells with compared to 5 gigahertz. So some things to take in what do you say? Something we need to think about when we're implementing and doing radio planning for a 6 gigahertz network is those quite smaller cells, right? So if we have a high density design network with 5 gigahertz for high density environments, we could use the same AP placements.
Because in that case, we will already take an account into that the cells are not that large.
Yeah,
right? So
we want to have small cells for the high density environments. So for the small cells, it will be the same for the 6 gigahertz. So probably use the same placement, but of course we always recommend to do a site survey to verify the 6 gigahertz coverage, and we aim for a minus 65, minus 67 around there at the Wi-Fi cell edge. And I would say that you can use the same AP placement in a high density. You don't have to move the brackets, just swap the AP and verify with a site survey.
And typically that would be like indoor environment, office environment, school environment and stuff that been for quite a while. We've been building quite dense when it comes to access points, because access points are typically lower their effect a little bit.
Exactly. And Cisco is also mentioning that if you have a transmit power at 3 or 4 level on your APs, then you're safe to swap the models from a 6 gigahertz AP from a 5 gigahertz and 2.4. 6 gigahertz is not available outdoors in Europe. This also means no external antennas, not even for the indoor use, like we have in some warehouses or auditoriums or
there are some sort of access point with sort of built-in directional capabilities, but that's the only way. Because otherwise, you will be too high with your effect out of the access point.
Exactly.
Violate the regulations.
So Europe has only approved low power indoor mode. We have a maximum 23 dBm EIRP. EIRP stands for effective isotropic radiated power. And it basically describes the effective radiated power from an antenna. And this isotropic antenna is a theoretical antenna that transmits perfectly equally in all directions. So that's just for a reference model.
So we're saying that you don't have to replace your design or anything. You don't have to redo your design unless you have some issues, right, in that environment.
Yeah.
But for new environments, yes, please consider that there's higher frequency.
Yeah. And you can also do before you do the physical replacement. You can do a planning mode site survey just to verify your from a planning theoretical perspective. Site survey is always important.
Mm.
To support all the new features with Wi-Fi 7, all the new high throughput, you need an infrastructure that's capable of this. For the wire side, we need to have multi-gigabit switch. It's not mandatory, but I would say anything under at least 2.5 multi-gig will limit the performance. And for the wireless infrastructure, if you're running a Cisco Classic 9800 wireless LAN controller, we need to be on the version 17.15.2 at least. And for the Meraki, we need to have the Wi-Fi 7 support came in 31.1. One thing to be aware of is in 31.1, if you have an access point transmitting WPA3 Wi-Fi 7 SSIDs, all the SSIDs transmitting from that access point need to be a WPA3 Wi-Fi 7 SSID. Okay, so you cannot mix a WPA3 Wi-Fi 7 SSID together with a WPA2 SSID.
Not in the current code with Meraki, right? So this just otherwise you have to stay with Wi-Fi 6 level. But this will change in the later this spring. But it's just be aware of that. That's something we found in the lab.
Exactly. So it's a temporary limitation.
Yeah.
But something important if you're an early adopter on Wi-Fi 7 for Meraki APs. And back to the wired, of course, we need to power. We need to power the access points. Regular PoE is not supported. I think we can call it legacy by now. Even PoE plus, it's supported, but with some limitation. You get lower radio capabilities. You only have 2x2 on the 2.4 gigahertz radio, for example. And this is with a 9176 Cisco AP example. And the multi-gig link speed will give you 2.5. Instead, if you have a PoE++ or Cisco UPoE, you get the full capabilities with a 4x4 on the 2.4 gigahertz radio, and you also get the full 10 gig link.
I mean, power requirements go up and down. It's sort of dynamic, but this is what you need to build it on the big.
Yeah, and one thing also worth mentioning that is really important is the power loss on the Ethernet cable, especially for longer distances above 50 meters, and when you're using the higher power consumption. And typically we recommend 6A, the preferred cabling. For the power loss on that cable is a few percent only. So the cabling is important. And our key takeaways from the technical perspective, I would say 6 gigahertz, big enabler for the next generation of Wi-Fi. Multi-link operational, huge benefit. It will be very interesting to follow this technique in the future. We're also getting more efficient on the medium with enhancements like multi-resource unit, preamble puncturing, and of course the security is a major thing with Wi-Fi 7 and the WPA3. And I think we will say a big thank you to Wi-Fi Alliance for pushing this in this new standard. We think your Wi-Fi 7 installation will be successful if you plan and design correctly. The switching infrastructure requirements will be with, you need to take into consideration the power and the multi-gig factor. And one key takeaway is also the radio planning is similar to 5 gigahertz, but the 6 gigahertz is just a bit smaller. So,
and the question if you should upgrade or not, we talked about before. I would say in general that if you're anything before Wi-Fi 6, then you can get plenty of value and you can get plenty of happy users by upgrading. And also typically you will see that for lifecycle reasons, if you are on any platform that is Wi-Fi 4 or 5, then that typically has lived its life in most scenarios. So, and also in general, with every generation, the radio capabilities, the radio quality of sort of the hardware goes up, I would say. So that's the takeaway. So that's sort of the wrap up today. I mean, thanks for listening. I think we will try to see if we can cover. I know we have some great support from Michael in the background here to answer some of your questions in the chat, and hopefully you got some answers to that. I'm gonna take a quick look here and see if there's any sort of questions we could highlight from the chat. So, are there any good?
Michael have answered some questions here. Let's see.
We got some.
Marcus has been answered.
Yeah, we had some on MLO. So the question is, I mean, how can we? What can we expect from MLO? I think that was also a good answer there from Mikael. And also some other radio questions. Are there anything we could highlight?
Wi-Fi 7 can't offer 6 gigahertz to, let's say, open guest networks. Or did I understand the segment correctly? Yeah, that's correct. Wi-Fi 6 gigahertz is then you have mandatory for WPA3.
Yeah,
and
that is also for Wi-Fi 6E or Wi-Fi 7, because I mean, anytime you enable the 6 gigahertz band, that means that you need to have a supported method that requires, in this case, an OWE and not an open network.
Yeah.
And we got some other questions as well. And also, I can also add to that, I mean, the PoE question is that the access point, the current versions will sort of start and they will go live, but I mean, they will shut down more or less every radio they have. So if you're on AF, then you're not good to go at this moment. You have to need an AT. Maybe there'll be, products also coming that might have different, things that you can drop down. But in general, I think that's not the case. I mean, so it's you need your PoE level to be correct.
And there's one question from Marcus here. I'm not sure. Oh yeah, Michael has answered that one.
The question seems to be, I mean, can performance be degraded actually by being connected to multiple radio bands at the same time? I think it's actually the contrary. I think the idea is to boost performance.
Yeah.
But then it needs to have a good way of distributing the traffic between. And I think we'll see a lot more going on with that in the future. For example, the ability to maybe say that, I want Microsoft Teams to always use 5 or 6 gigahertz.
Yeah, exactly.
I mean, that's when we really want it to work the way we should.
So we're probably not going to see Microsoft Teams load balancing on different links or different frequencies. So if you are using MLO and you are doing throughput testing, that specific application will only use, I think, one of the frequency at that time.
Yeah.
So it won't go, the throughput won't go above the limit of that medium. If that's
I would say MLO is really sort of new, and I think that's where you will sort of see issues that sometimes it will work great and sometimes it won't work as great. But I mean, in general, it's still a good thing, and it's still good that the Wi-Fi Alliance requires a Wi-Fi 7 certified device to fulfill those requirements. So I would see, I mean, in the next half a year, I think we'll probably be aware of those issues, but they will go away. And I see already that with new drivers, and I know Intel, for example, had some issues with MLO. and also Windows 11. It needs to have a fairly new version of Windows 11 to really get those enhancements in. So I mean, and also as always, we keep your details there. If you please reach out to us if you want to sort of.
I want to do a shout out here. We have a question. Any real data from test of MLO, white papers, etc. We have a colleague in Norway, Kjetil. He is running a YouTube channel, and he's doing a lot of testing for Wi-Fi 7 regarding preamble functioning, multi-resource units, MLO. So he's from Conscia, Norway. But we have not done any.
No,
any
we
testing.
decided not to do that because it's all over YouTube and Google. If you find the different ways of people testing, but from our perspective, you'll see 2 plus 3, 4 gigabits of throughput and latency really going down. And don't worry, I mean, thanks for your time from us, and also Wi-Fi 8 is around the corner, so stay tuned on that. And then in that case, it will be talking about the client actually being aware of multiple access points and vice versa. So there will be multi-access point coordination, and typically you'll see even more deterministic latency. So if you start deploying Wi-Fi 7 now, you'll be done by the time Wi-Fi 8 comes around 2028, something like that. So that's around the corner, but that's really nice. There's always development going on. So yeah, and also other questions. I mean, time's up, so thanks for listening in today. Hopefully you got some good insights on how to deploy Wi-Fi 7. So any other questions from the chat?
No. Doesn't seem like there is. All right. Thank you, guys.
Yeah, thank you.
It's been very fun.
Take care.